Yes. So today is day 2, right? Yeah. Thank you, Hari. Thank you so much. So yesterday we have started this training program. Yesterday we discuss uh, the introduction of the electrical power system network, right? That we discussed yesterday. So any query from the study session? Yeah, Rashmita. Good evening. Good evening. Yeah. So today day 2 and
सर आई हैव ए क्वेरी तो आपने जो इस बुक से कल एक
see, one second. Indril.
इंडोनील सर
Yeah, please come into English because many few other students that is from South India and the
सर सर यू गिव मी द प्रीवियस डे गाइडेंस गाइडिंग पेपर बी डबल ई लाइन और एक्सेट्रा सो हेलो
yes. Okay,
गिव मी द रेफरेंस गाइडलाइन
standard right now.
यस सर
Okay, sure. Okay, I think yeah, already given. Okay, until I'll check and will again update you where you can found that is already given. We'll check and if you not found, I will
ओके
resend.
सर ओके सर ओके
Okay, so day one, what we have discussed, that is the introduction of the electrical power system network that we have discussed. Let me open that presentation again. Yeah, so we discussed about the responsibility or what is the main sting for the electrical engineer. Then we discuss about the uh, main components of electrical power system that we discuss. Thereafter we discuss about the different generating plant, and then what voltage we generate, that we discuss. And when it comes to solar, then generations again very less, 600 or 800 voltage that generally we generate with help of the PV cells. And thereafter we have the inverter duty transformer. With help of this transformer we step up this voltage to 33 or 11 kilo voltage, and that further we feed to power transformer, and that we again step up and feed to the grid. So this is what we generate with help of the solar PV cells. And this we the generating voltage we discuss, and thereafter we discuss that why we require the substation, transmission and distribution. So the conclusion was that due to the limitation of the resources, the generating power plant located far away from the end consumers, and we are generating the bulk power. So to transfer the bulk power at the less voltage, the losses will be higher, so it is not economical. Due to that reason we require a generating subsystem. With help of that we step up the voltage, and the in higher voltage you will transmit with help of the transmission line. So this transmission line is connecting that generator to the grid, and further we distribute to the end consumers. So we discussed that why substation, transmission line and distribution networks required, right? This is the overall picture of the grid that we discuss. Yeah, Raghunath, I think it is started. Yeah, already started, Raghunath. Yeah. So here we see that when we plan any transmission line, so we have to perform the route survey, and the surveyor will propose three alternative options: alternative 1, 2, and 3. and based on that, what is the shortest route that we choose for the transmission line. Okay, then, and power we transmit with help of the series chain of the substations and interconnected transmission line. Robotic means, what is robotic? Yeah, rodeo. Yeah, for others spice is clear. Let me check with the others. Yeah, yeah, what about the others? The audio is okay, or should I fine tune? Check.
Oh, it is good.
Yeah, clear. Okay, okay. Right, so we discuss here about what is the purpose to have the substation, then transmission line, distributions line, all these things. Yes, it depends again is the minimum maximum length of to transmit the voltage is yes, we have. I will explain you with help of the ETAP. Okay, then it have the length, right? Thereafter we comes to the generating substations. So we discuss here type of the substations. So that also we discuss yesterday. So we discuss about the electrical power system network, and then we discuss about the type of the substation. Okay, then we discuss why substation is that also we discuss why substation is required. So anyone can explain in a single statement that why we require the substation, why we require substation.
To step up or step down voltage.
Yeah, so substation is required to step up the voltage near to the generator. We have the generators here. We require the substations in order to step up the voltage. So here we step up the voltage with help of the transformer. Then we transmit with through the transmission line, and then again we require the substations to step down the voltage, and then again we can feed to the different local distribution substations, and that again step down the voltage based on their geographical regions are requirement. So we require the substations that first of all it will step up the voltage, up voltage, then transmit. Here we have the transmission line, overhead transmission tower we can say. Then again we require the substations to step down this voltage, and then again it bifurcate or distribute to different geographical regions, and then again it will step down, that is suitable for the local distributions or the local industry. So to step up the voltage and step down the voltage, and in order to step up the voltage and step down the voltage, we always use power transformer. We always use the power transformer, right? So with help of the power transformer, we will step up and step down the voltage. Let me have a quick review on the power transformer. Even though we have the dedicated module for the power transformer, so this transformer we can divide into three part, or let me take the power transformer only, not the type of the transformer, power transformer. So with help of based on the voltage level, this power transformer, there is many types that we take. We can take two winding power transformer. Then we can take the three winding power transformer, and three, or we can say the multi winding power transformer, three or five winding or multi winding power transformer, or three winding we can write here. And thereafter we have the single winding power transformer, and that single winding power transformer we call as auto transformer. So can anyone tell me that where we use auto transformer, where we use the three winding transformer, and where we use the two winding transformer in this power network, in this electrical power system network. Yes.
Sir,
Yes.
hello.
Yeah.
Sir, when HV and LV ratio is greater than 2, then we use two winding transformer.
Yeah.
And when HV and
Yes.
LV ratio is less than 2, then we use auto transformer.
Yes. So the point is that whenever this voltage, this HV voltage and LV voltage ratio, because we have the transformer, so we have the high voltage side or primary voltage, or the secondary side or the LV voltage. So whenever this HV high voltage side to the low voltage side, or we can say the primary to secondary side, in a simple statement we can say like that also. So whenever the HV and to LV voltage ratio is greater than 2, in that case we refer to use two winding type power transformer, and that is the reason every generating power plant have two winding type power transformer, because they generate the 11 kilovoltage and then step up to 33 kilovoltage, or 33 kilovoltage is generate, then we step up to 132 kilovoltage or 220 kilovoltage. So the HV to LV ratio, suppose 33 by 11 kilovoltage we have, so this ratio is greater than 2, that is 3, right? It means that is greater than 2. If there is 220 by 33, 33 we generated, then step up to 220 kilovoltage in that case. So this again ratio is greater than 2, right? So whenever we are talking about this generating substation transformer type, right? So the substation that is placed near to the generator, that voltage ratio will be higher, always higher than 2. They always prefer to use two winding transformer. Whenever we have the two power generating source, suppose we have the combined cycle power plant, we have the gas, we have the steam, or we have more than two power sources, in that case we have three winding or five winding or more than two winding power transformer. In that case what we do, we take one power from the one GT, we can say, or one resources, or one power we take from the steam turbine, that is the gas turbine, suppose we are telling like that, and then we step up both the power and then we combine one to one power, one voltage, and then this we feed. So in that case we refer to use three winding type power transformer. That is typical example of this three winding or five winding is the solar power plant. Solar power plant, in the solar power plant we have the many PV cells. So from the different PV cells we take supply and we feed to one common inverter duty transformer, and from with help of that we step up and then we feed power to the next power transformer, right? Yes.
Hello.
Yeah, tell me.
Actually, in normal substation also, grid substation also, we are using tertiary transformer, sir.
Yeah, I'll come on that. Tertiary transformer, tertiary winding.
Tertiary. Actually, if you have 66 kV input and output is 33 and 11, simultaneously we can put to one transformer, single transformer. Then from one side it is 66 kV, one side 11 kV, and one side is 33 kV.
Correct. So
Like
that is the case, right? Now this one.
Yeah.
This one we have.
Okay.
So whenever we have this one example, when we have two sources, that is that one example is that. Second example we can do solar power plant where we have similar sources but we have different places of the PVCs. And third we can say when we have more than two voltage level, like 11, 66, 132 kilovoltage, we have more than two voltage level. In those cases we prefer to have three winding power transformer, right? I hope this is okay now. This one, two different
Yes.
source solar power plant that we use three winding, and we have more than two voltage level, or maybe that is 11, 66 or 132, like that. in that case we prefer to have 3 winding power transformer, and that we will place here, right? And when it comes to the power transmission, when we have the grid substation, not the distribution type, this substation, suppose we are taking this 400 kilovolts step up with help of this generating substation, then we step down this 400 to 220 kilovoltage, and this 220 kilovoltage we are feeding to different other substations, that is step down to 132 kV, 132 kV, or step down to 33 kilovoltage, maybe, right? In that case, so whenever the HV to LV voltage ratio is less than 2, example this 400 by 220 kilovoltage, example 220 by 132 kilovoltage. So in that places, in those kind of the substations, we will use auto transformer type power transformer that have one single winding, that have one star single winding, that is a star connected, and in order to balance the third harmonic they will have one delta connected winding also, right? From here we can place the tertiary route, but this is not the third this is just the balancing, they are doing just power balancing, harmonic balancing they are doing here. So but this is winding wise, we have one winding, like this case is like that, this is the one winding between the primary and secondary, and here we are doing some, here taking the tappings, this is 400, here HV side 400 kilovoltage, this side 220 kilovoltage, and here we have taken the tapping this much, and here we are putting some load to balance the VI or to eliminate the third harmonic, and we connect into delta for that. So if we have the substation where voltage ratio is less than 2, example 400 by 220 kilovoltage, for example 220 by 132 kilovoltage, in that place we will use auto transformer type transformer. So this is the network, and this step up and step down we do with help of the transformer, and we have this kind of the transformer that we use in order to step up and in order to step down the voltage. So this power system network we have seen in the day 1, right? That already we have seen. So generating substations we seen here about the generating substations, then we seen about the grid substation. So we also discussed day 1 about the type of the substations. We discussed about, yeah.
Sir, what is a tertiary winding? Any idea?
This one tertiary winding. Acharya, please wait. Now we have one dedicated module on the transformer. Okay.
What is the role of tertiary winding?
We have one dedicated module for the transformer. I'll come on that. I'm just telling you the type of the power transformer. Do not mix. Today is not a transformer discussion. Today is day 2. So we will take one project. We will download one tender, right? And for the transformer we have one dedicated module, in that we will discuss in the detail about the transformer. Okay, you have asked, so I'll quickly reply. Now tell me what is your query? Yeah, this use of this tertiary winding, right? Now what you ask?
Yeah, sir.
Yeah, this
I have no idea what is a tertiary winding.
tertiary winding have the two role. First role, they will feed the auxiliary loading. They will feed with help of this transformer, and second, they will do the power balance, the power balancing. What is the power balance? We will explain. The EMF balance, right? And third rule of this winding is to eliminate the third harmonic or the multiple of third harmonic. Okay, so this is the main rule, but we will discuss again in detail about all these things, all these responsibility, all the use of this tertiary winding and why we connect into delta, what is the reason behind that. Okay, Acharya?
Okay, sir.
Yeah.
I have a doubt. Sorry. Hello.
Today is not the transformer type selection. Today is tender selection. I think the course agenda already shared with all of you right now. There is
So is the main reason for auto transformer like isolating an electric circuit from another circuit, or it's like quite widely used for distribution as well?
okay. Let me tell. Today we have finalized the agenda, right? So we'll go based on that agenda. And if anyone have any additional query that is not as per our agenda, so that we will discuss in the last. This is our agenda today. A review of the basic structural electrical power system, grade why substation is required, process involved in assessment of new substations, introduction of ETAP software, download the tender, warranty effect by ETAP, listing of all IC and IEEE standard, review the design basic report, designing process steps, construction, what are the total steps involved for the overall construction of your project, and then Q&A session. So in the Q&A session I will take other questions, right? So you please all note down your questions. Let me complete my today agenda and thereafter we can discuss all your query right now, because the class flow should not interrupt. That is the reason.
Okay, sir. Okay, sir.
Because if we go to the discussion, so we are not able to complete my syllabus, my content. Let me complete my syllabus, my day agenda. Thereafter we have Q&A session, and whether all of you available on Friday also, so that we can plan some additional session on the Friday also.
Okay,
If
sir. I am
you
available.
okay, so if
Yeah,
you
Available,
so,
sir, no problem.
so we can plan one additional session on the Friday also, so we can have class Friday, Saturday, Sunday if it is possible from my side also.
That is better, sir.
Yes, we'll try to that. We'll try to that.
Yes, sir. Available, sir.
Yes. So we will try to that. Okay. Yeah. So how we will do this study? How we will do the study? First, we will complete our class agenda, our topic as what we have listed out. And if you have any query regarding that topic, so we can discuss that topic. So this topic query is welcome, but any other query that we can have a session in the last. I hope that is okay for others right now. So we'll take a class agenda, we discuss that agenda, that query regarding to that agenda, that we can discuss simultaneously. No need to hold, or no need to, you can discuss simultaneously. But if any other query that we can have in the last. And even though if you come into the syllabus, let me open the syllabus. If I have, if yes, so you see you are asking a lot of questions on the transformer. We have one dedicated module on the transformer, selection of the transformer, 2 winding, 3 winding, auto transformer requirement, tertiary winding in transformer, reactor, cooling type, 3 tap, OLTC selection, OLTC calculations, impedance selection, industrial practice for selection of transformer, ratings, sizing, nameplate, protection, difference between REF and differential, vendor drawing review, comment, approval for manufacturing. So in this model 3 only we are going to discuss for the transformer. So all your questions will be addressed in the module number 3. So please go through as per the syllabus. First download the project. First take the tender. Start working on that tender. I hope that approach is fine right now. If anyone have any other uh, opinion, they can suggest your feedback. If anyone have any other feedback, please let me know.
Okay, sir.
There is a lot of syllabus actually, so we are trying to keep, and Friday class also, and we are trying to keep within 4 months. So we'll go in this syllabus wise. Okay, so even though this was not the topic for the today, but I was telling that how we do step up and step down the voltage, so I said that we use the power transformer. Okay, so okay, let me now reply the queries what you have asked now. I did not wanted to leave any query. The ratio limit is H2 for transformer type selection is based on what factors? So Silpa, we discussed now that what about the type of the power transformer. That is the one type that we take two winding, we take three winding, or we take auto transformer. There are many other parameters. Based on that, we select the transformer. That is, we discuss here. We discuss now. What is the parameters? Based on that, we select that which type of the trafo I am going to take here. Right. Let me ask you one basic questions. If anyone asking to all of you, what is the type of the transformer? So what should be your reply?
Lots of transformer available, mainly for generation, distribution, and transmission, and other frequency changer substation. Lots of transmission is available.
Okay. During interview, I asked you what is the type of the transformer. So yes, a lot of transformer is available, but what is your reply?
Power
Based
type
on
transformer, instrument transformer.
Power transformer and distribution transformer.
So depending on the voltage, that is step up, step down, depending on the core type, cell type,
Okay.
transformer.
Yes. So core type and cell type. This is the type of the core. This is not the type of the transformer, right? Step up and step down. See, trafo is not a trafo is bidirectional device. With the same trafo, we can step up the voltage, we can step down the voltage, Rahul. So that is not the appropriate and correct reply. Let me add my opinion. If anyone asking what is the type of transformer, we should reply in this way: type of the transformer, type of transformer. So we should reply that we have three kind of the transformer. One is the distribution transformer. Second, we have the power transformer, and the third we have the instrument transformer. They use the power transformer handle the rating into the kVA, used to distribute the supply, to distribute the electricity to the end consumers, to the end users, right? Power trafo rating comes into the MVA, and that is used to transmit the bulk power, to handle the bulk power, and that is in the MVA. And this power trafo, again we have three type of the power transformer based on the voltage that we select: two winding, three winding or multi-winding, and the single winding or auto transformer, right? And then we have third is the instrument transformer, that is again further divided into two types, that is the CT current transformer and the voltage transformer. And the use of instrument transformer is to step down the voltage and to feed the voltage or current to the measuring relays, to the connected instrument and the relays, to the relays and the measuring instrument like ammeter and the voltmeter. So that is the type of the transformer. Now if you are telling step up, step down, trafo is bidirectional device. They can step up the voltage, they can step down the voltage. And due to the bidirectional nature we have in the transformer, that is why the solar substation exists in the world. Otherwise solar will not exist, because we take supply, we feed supply during the daytime and we take supply during the night time. So that is bidirectional nature of the transformer. Okay, if you talk about the core and cell type, that is the core construction, that is not the type of the transformer. If you are telling the oil cooled, liquid, the dry type, oil type, so this is the type of the cooling, not the type of the transformer, right? Okay. ON, AN. So this is type of the cooling, not of type of the transformer. I hope you agree with this classifications about the transformer. Other things what you talking, that is the manufacturing type, not the type of transformer. I hope you agree with this classifications. Yeah. Yeah. Yes, Mansoor sir. We will record. Yeah, that's again we have the directional transformer that we use. We have inverter duty transformer, that these are the type of the transformer. That is Okay, I hope this classification of the transformer is okay for everyone. And now we close this topic. I hope I replied to everyone's questions. I was just review the class day 1. Okay, so yeah, then we discuss about the classification of the this type of the subsystem. We discussed that what type of the switch yard we have. Now I can erase this right now. Anyone have any query? Let me know. Otherwise, I will erase this. So now we are closing this trafo topic. Moving to the subsystem. So we discussed about the type of the subsystem that we have. So we discussed that we have generating substations, we have the grid substation, and we have discussed that we have the distribution substations. This we discussed. Thereafter we discussed about type of transfer based on the cooling medium. So based on the insulating medium and based on the locations, this we can divide into the air insulated substation, we can divide into gas insulated substations, or we can divide into the hybrid type substation where we use AIS plus GIS, both we combined. GIS is outdoor type here, not the indoor. So AIS, that is outdoor, then indoor, and indoor again we can divide in two parts, the panel based indoor or the gas based indoor or the GIS module type indoor. Outdoor, indoor tube type, and then hybrid. Hybrid is outdoor, but they have combination of indoor air plus gas type switch gears. So this we have discussed right in the day 1. Day 1 we discuss total overall network that we study in the college time. So the in conclusion is that the purpose of substation is to step up the generated low voltage electricity from the generating subsystem and enable for transmission, and then receive the power from the transmission system and step down the high voltage to lower voltage electricity, so it can be easily supplied to end consumers like industrial consumer or domestic consumers through the distribution lines. That is the conclusion that why we require the substations, and we will discuss in the detail about the designing of this substation, right? So to design, to construct this substation, what is the list of drawing required? So that we discuss here that what is the list of drawing and document required to make any kind of the substations. So single line diagram, electrical layout, plan and sections, TSLD calculations. So these are the drawings: structure layout, foundations, cable, trench earthing, erection K diagram, and then we have this equipment list. Then we have this VMS, PLCC, fire protection, cell, switchgear, battery, and battery charger, DG. That all also we need to include here. Then we discuss that when any job openings come, so what is the specific area of responsibility comes for a design engineer or a design manager. So here we discuss that engineer need to prepare the EHV system single line diagram, layout, design of switchyard layout, plan, section, EKD, clearances diagram. So that engineer need to prepare all these drawings. Preparation of equipment sizing, calculations, site tensions calculations, institutional coordination study, preparation of technical specification of equipment, vendor drawing review of EHV system, that we also discussed the vendor drawing review, transformer, cable, switchyard, follow internal and D&D design engineering process including all database and report management activities, provide internal design team and cross-functional coordinations for the design of it. Cross-functional coordination means you have civil team there is a civil team, HVAC team. So for that we do the cross-functional coordinations for the design update, field suggestions, specifications for service and construction related items. So engineering support, bidding support, and then desired profile. Skills, expertise on various EHV system, AIS and GIS, transformer cables which are up to 400 765 kV preferred. They require 400 kilovoltage, but they prefer who have knowledge about 765 kilovoltage. So till 765 kilovoltage we will discuss in the class. Subject matter expert on EHV system component selection. So for that we have one dedicated module, module number 2 and 3. In that we are going to discuss about the equipment component selection. If we come on the syllabus, so 2 equipment selection, and then 3 also equipment, that is transformer, their selections. So they required this subject matter expert, knowledge of auxiliary AC DC system, hands-on experience on overall design quality and code checks. So we'll discuss about the code, what is the code required, sound knowledge of relevant engineering codes. So first of all, we should know that what is the engineering codes that we have, and then we have to read out that engineering codes. So today we will list all the engineering codes that we use for the substation designing. Knowledge of control and protection is desirable, so that also we'll discuss control and protections, right? So we discussed yesterday about the job descriptions, how it come into market. So we have to enhance, or we have to make our skill based on the job descriptions, so that we can put all these in our CV and we can forward CV to company, and based on that, if we are matching the skills, so the shortlisting possibility will be more, right? So today agenda. So any query so far from the day 1 class? If no, so we can proceed with the day 2 agenda.
Sir, no query.
Yeah, yeah, Acharya. Anyone have any query? Now, I think you are aware that what is the syllabus, how the job comes in the market, and if you work on any subsystem, so what kind of the document you need to prepare, right? So now we are ready. We can now start the project designing. Anyone have any query? Please let me know. Okay, so I hope everyone understood now. Okay, so let me take. So when we start any project, let us start any project. Okay, so let us select a project. We start from a project selection. So for the project selections, we can take any project. Let me check online that can we download any project. So we can go to the REC TBCB tenders, that is tariff based competitive bidders, and we can check if what is the live tenders going on. Then we go to the tenders. REC, the Rural Electrifications Company, that is the Rural Electrifications Company. This is one India based company, that is responsibility of this company for the electrifications. And now here live tenders, we can go about us, about the REC. REC came ongoing 1969 to articulate response to present nation during the, this is Navratna company in the Ministry of Power, and then this is the Power Development Consultancy Limited, and then we can go to their tenders. So here we have the live tenders. Tender detail, last date of tender submission 14 April 2020. So we have 1 month, 2 month around time for submit of this tender. So request for proposal document for selection of bidder. So this is the tender detail. As transmission service provider through tariff based competitive bidding process to establish interstate transmission system for transmission scheme for solar energy zone in Gadag 1500 megawatt Karnataka, part A. So this is a Karnataka based tender. So let us see. Yeah, standard single stage request for proposal, that is called the RFP, request for proposal document. For what? Selection of bidders as a transmission service provider. Okay. Then this is the Power Development and Consultancy Limited, their office in New Delhi. And now for this project, this is, so first of all we need to download a project. We can take one live project. So this is a live project that is going on. Okay, Mehul, try to do that. Mehul, please note down all your queries. In the last we can discuss. Okay, we haven't given this. Okay, so this is the project. So we can download this tender. So from here we are downloading this desktop, and then yeah. So this project we download. We just wanted to take one project as a reference. So whatever we are discussing, that discussions we can apply in that project, and for that project we will prepare the drawings. So this is the project that we downloaded, and we wanted to have a recent ongoing project or the new project. Okay, so when we download any project, so how to read any project? Like when you downloaded the standard, so how you will study this standard? What is the step number 1? How to read any tender? Yeah.
Mainly transparent and kind.
Yes, so how to read any tender? What is the step from where we will start? Yeah, Sankeet, correct.
Scope of work.
So first we will see that what is the scope of the work. So here we can see the scope of the transmission scheme, scope of the work. Or let me see if any other place they have written the scope of the work. So first of all, we need to go and we have to check what is the scope of work. Introduction about the company, Central Electricity Authority. Yes, and that TSP will be required to establish the following interstate transmission system, and this is the scope of the work that we have. So first of all, we have to read what is the scope of the work. Power system 400 kilovoltage high capacity equivalent to quad MOS. DC stand for the double circuit line. So here we have to make the transmission line only, that we can see. Two numbers, 400 kilovoltage line base at each end of the this and this substation. 400 kilovoltage double circuit line, 400 kilovoltage line bay. So we have to make 400 kilovoltage line bay and 4 numbers. So 2 numbers at this place and 2 numbers at this place. If anyone have any query, any difficulty, please let me know. And now you can discuss, because this we are discussing. So in that, if any doubt, you can take. It means this is one place of the substation. Right now, let me take this snip and we can explain. So what is the meaning of that? That we have one substation that is placed here, and the name is G. Actually, the name of substation come from the place name, so that is the place name. And this is the next substation, and this name is KOPPAL. And between that, we need to connect 400 kilovoltage double circuit line, as we can see here. 2 line we need to connect. So we have to make this transmission line first of all, and this transmission line is coming from this substation. So for that, whatever the line bay required, we have the bus bar, and from that this line bay will come. So this line bay we can delete this, we can take this one, and then again circuit breaker, and then from bus bar. So one line bay is that, and second line bay, this is the one transmission line bay. So this line bay here we have. So what is mean that in these substations we have to make this 2-line bay, and here we have to make 2-line bay. So total line bay will be 4 numbers, as you can see here, right? 2 here plus 2 here, and thereafter we have to make the transmission line. Right now, that we can see here, we have to make the transmission line, and that transmission line, so we can take any picture like that, any transmission line picture we can take. So this is one transmission tower, right? And from here we have the cross beam circuit 1. This is here we have. So R phase, Y phase, and B phase. So this is the one circuit, R phase, Y phase, B phase, and here we have the next circuit, R, Y, and B. Y and B. So line 1 will go from this side of the tower, and line 2 will go from this side of the tower. So this is called circuit 1, this is called next circuit. So both in combined we call as the double circuit, DC line. I hope you now clear what is the meaning of DC line. D/C, this word is clear, right? And why 4 number line bay? I hope this word is also clear. Am I okay? Actually, during the class, I need
Sir, can you please
yeah.
that 4 number line way? Can you please come again? Because I have some doubt. Can you please
4 number
come
line bay.
again on that?
First of all, you understood there is 2 substation,
Yeah, yeah.
and between these 2 substation, we need to connect 2 line, right? Now 2 transmission line.
Correct, sir.
So 2 line bay will come in this substation, or not?
Okay. Yes, 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 yes.
2 line bay will come in this substation or not?
This subject. Yeah, got that, got that, got that.
Please concentrate in the class, because already we
Sorry.
have explained.
Yeah,
Please pay your full attention for the next 2 hours. That
yeah.
is required, because we have a huge syllabus and we wanted to cover a lot of things during this syllabus, and keep this training program your final training program, so that after this program you should be enabled that you can make drawing independently without any help. So that is the agenda. Quad moves name of the conductor. Mehul, name of the conductor. It means we can take any line again. Let us go to here. Let us go to here, and we will see here. Let us transmission line. Let us transmission line. Okay, let us take the image. Yeah. Yes, we can take any transmission line. That you can see there is a 4 conductor per phase, right? R phase, Y phase, and then B phase, RYB. 4 conductor per phase. So that is called the quad. So this is transmission line. This is transmission line that having the 4 number of conductor on the R phase, 4 number of conductor on the Y phase, and 4 on the B phase. So this 4 in terms of the power transmission system we called as the quad, and moose is the type or name of the conductors. And you don't worry if you are not able to understand, we have one dedicated transmission line module also. In that we will discuss again all these things. Okay, but I think this is clear, right? Power station, yeah. Substation, yes, power station like that. Yeah, so this is what this tender is telling. So let us take one another tender, and which from the last 1 year we are working that, because here we have only line base, so we required all kind of the base, not only the line bay. We should have the line bay, we should have the transformer bay, and we wanted to have one new substation. This is the extension of the substation only for the line bay. So let us take another type of the tender that is new project, and that have all kind of the base, line bay, transformer bay, and not only the line base. So I'm referring now to my working project. So but yeah, first of all we have to read the scope of the work, project execution. So this is, they have given about the project brief introduction, transmission scheme, solar energy zone. So there is a solar zone, actually zone 1 and zone 2. So from that zone they are interconnecting. And yeah, PS stand for the pooling stations. Now it is clear, right? Power station or the pooling station? Okay, Salis, pooling station. Yeah. Okay, so first of all we need to go to the scope of the work. So we'll take one tender. So I'm going to take the project on which we are working. So this one also you can go through, you can read out, and if any query you can discuss with me. But in place of this I'm going to take the another project. Ramatullah pooling station we make near to the wind farm or near to the solar farm, where we pull the power from the solar or the wind farms, and then we step up and then we feed to the grid. That is called the pooling substation. It comes near to windmill and the solar farms. Clear, Ramatullah? Yeah. So coming to the another tender, let me take that project on which we are working from the last 1 year. What is the tender? Yes, in the last batch also have taken the same tender, because on that time we have started this tender. So I'm going to close this. Yeah, total generating firm power, Rohit. Yes. So let me take this tender and let me put here in the folder. So this is our tender, RP tender. Yes, RP stand for the request for proposal. Same company, REC. So same tender we are taking, that we have downloaded. Okay, so now as we discussed that when we start any tender, any project, so first of all we have to read the scope of the work. So let us come to this project and let us see what is the scope of the work. So here we have the scope of the work. Yes, transmission system strengthening in Jharkhand state, package 2, scheme or transmission work. That is the scope of the work. So what is the scope of the work written here? Establishment of new 400 by 220 kilovoltage, 4 by 220 kilovoltage voltage ratio is that, right? So what kind of the trafo we will use, what kind of the power transformer we will use here?
Step down.
Step down is fine, yeah. That is not the type of the transformer that I explained in the beginning, type of the transformer. No step down, no step up.
Two winding.
You prefer this one.
Two winding transformer we are going to use.
No, we will not use two winding transformer here. Not
Auto transformer.
Auto transformer.
Auto transformer.
correct now, because the voltage ratio is less than 2.
Less than 2.
So when the voltage ratio is less than 2, in that case we will use the auto transformer. And now you can see what is the word here, ICT. So what is the meaning of ICT here?
Interconnected transformer.
Okay, so interconnecting transformer, it means interconnecting transformer. So if you see any two winding transformer, let me take any two winding transformer. So here we have the system. This is 220 kilovoltage I am taking, or in 33 kilovoltage I am taking. Step down to 11 kilovoltage, and then we connect to this system, right? This 33 kilovolt system and 11 kilovolt system. So what is the actually in the power transformer, this HV side, this side circuit and this side circuit, this is coupled magnetically right now. That is magnetically coupled, but electrically not coupled. Am I correct? Because power transformer working on this principle right now, HV side and then LV side. So between the HV side or 33 kilovoltage side and to LV side, that is 11 kilovoltage side, there is no any electrical connections, right? Am I correct?
Yes, sir.
Only the magnetic coupling, right now. Only the
Yes, sir.
electromagnetic
Electromagnetic neutral is there. Yes.
only the magnetic coupling happens. So when it comes to single or auto transformer, so what is the circuit of the auto transformer? That is this kind of the circuit we follow, right? If you remember your engineering time, so we have this kind of the winding, and we take the tappings right here, right now. This is my HV side, and here we have my LV side. Am I correct? And here we put my so this total voltage here is 400 kilovoltage. So I'm taking the tappings from this part of the windings, and so we are telling that this is the 220 kilovoltage with help of this winding ratio that we are going to tell. It means this HV side and LV side both are electrically connected because we are taking the tapping. So both side is electrically connected, right? Or not?
Yes, sir.
So when both side is electrically connected, so I will say that is this is interconnecting transformer. Interconnecting transformer. Am I correct? Interconnecting,
Correct, sir.
connecting
Yes, sir. Yes, sir.
transformer. So I hope now you are comfortable with this word. You are comfortable with this word ICT. So in place of the two winding transformer or three winding transformer in this tender, the client written as the ICT. So whenever you see ICT word, you need to understood that this is the auto transformer. This is this type of the transformer. Okay, so here we will use the auto transformer because voltage ratio is less than 2. Okay, and this is the power rating of the transformer. And as we know that use of the substation is to step up the voltage and step down the voltage, and this step up and step down we do with help of the power transformer. So here we are going to step down the voltage from 400 kilovoltage to 220 kilovoltage, and with help of a 500 MVA power transformer rating. And this substation is placed in Dumka, that is the place of the substation. And to complete this substation, the client have given the 38 month. So as a contractor, you have to make these substations. You have to do the designing, erection, testing, commissioning. You have to charge and you have to hand over this within 38 month to the owner, to the client. And that client is this REC or Jharkhand State Electricity Board, maybe. Right. So whenever we take any tender, first of all, so now we are entering into the detailed designing portions. So suppose we are working as a reference, we have chosen a construction of a substation project. So this is the snapshot I have taken. Project voltage 400 by 220 kilovoltage owned by the REC transmission company. My slide is okay, or should I need to zoom? Yeah. Okay, and let us suppose that our role as a design engineer. So let us suppose we all are working as a design engineer in any EPC contractor firm. That company take the contract, and in that company we are going to suppose that we are working as a design engineer, or we can say the design manager, and we are the in charge to designing of these substations. And here the client are owner. So if I am telling the client, in that case, what is the client? So client will be this owner of this company, owner of this project. So who is the owner? That is the REC, or who have called this tender. So this is my issued by this company. So we can see this company is owner, or this company is the client. This company is the client. So we contractor, this company is the client. So if I'm telling client as per client specification, as per client specifications, it means I am telling that this is the client and this is their specification. This is their specification, that is 142 page document. So that I am following this document if I am referring that as per the client specifications I have taken, I have chosen, right? Okay, then they will so further, based on the given scope of the work to EPC company, they will do construction of project within target completion date time. So target time is for this project is 38 months. So within 38 months they need to complete this 400 by 220 kilovolt substation, right? Target completion time. And being design engineer, we need to prepare the drawings for the site construction. So based on our drawing, here the snapshot of a drawing, we need to prepare the drawing, and based on that drawing the site construction work will be executed with related sub. And we need to prepare the drawings, we need to prepare the calculations, we need to prepare the BOQ or BOM estimation, equipment selection we have to do, and sizing calculation of the equipment to be used at the site. So based on list of drawing and documents required by the client, we have to do all the activities for this project. So I think our all of role is clear. So what is our role? Our role is design engineer. This is the project, and who is the client? So REC is my client. REC is my client. For that we are going to work. For that we are going to work. So this company, Rural Electrifications Company, REC, this is the client. So this is the tender specification. So how we read out this tender? So this is this. First of all, we have to go to the scope of the work. So here the scope of the work. So let us understand this scope of the work. First of all, then we will go to the other tender study. So establishment of a new 4x220 kilo voltage substation that have the transformer that have the 500 MVA capacity. Place of the substation is Dumka. New 400, and now the 400 kilo voltage side. This is the work that we have to do. So we have the line bay two number line bay, ICT bay two numbers. It means first of all we should know what is the meaning of the bay. So I hope that you all is okay. What is the meaning of the bay? So ICT word is, everyone is clear what is the meaning of ICT. 400 by 220 kilovolt is step down the voltage with help of this 500 MVA power transformer. ICT bay. So what is the ICT bay? What is the line bay? Since this bay word is clear to all of you. If no, please let me know. I will again repeat what is the meaning of bay. And I need the active participation from all of you. Please use the chat box. Please be active on the chat box.
Kindly repeat
What is the bay?
Salis. Okay. Okay, let me ask that I have shared some few classes recording. Have you all checked that recording? I don't think you have checked all those recordings.
Check it, sir.
Oh, you are totally dependent. I have shared the classes recording.
Page. They using say transmission line.
Okay, no it's welcoming on that. So I don't think there is any use of share the previous best class recordings because you are not going to go through that recordings.
No, sir. We are.
Okay, so let me tell you about what is the pay. What is the pay? What is the
Okay.
pay? Yes. So bay means, yes, bay means uh, bay means we can see the electrical circuit. I mean to say what I can tell. Bay means we can say that that is the electrical circuit. This refer to the bay. Actually, in case of the power system, we have two word. One word is the feeder. One is the feeder, and second word we have the bay. So feeder means when the voltage level is HT, that is 11 kilovoltage and 33 kilovoltage. So for this voltage we called as the feeder. That 11 kilovoltage feeder, 33 kilovoltage feeder. It means there is a power house, and from this powerhouse you are taking the RYB three-phase circuit, and you are connecting to your industrial load. Suppose you have your own industrial load, and that we are connecting to that industrial loads. So this is we called as the feeder. R phase, Y phase, B phase. And as we know that the power system have the three phase right now, R phase, Y phase and B phase line, like R circuit, R phase circuit, Y phase circuit, B phase circuit. So when we go to the this substation, in that case, in place of the circuit, we call as the feeder, we call as the bay. And when it comes to the distribution line, then we call as the feeder. So feeder or bay means the circuit, the electrical circuit that have the R, Y and B phase. And this circuit we recall as the bay, and R we recall as the feeder. This is the name of the circuit. Okay, coming back to this tender again. I hope now bay is clear, or should I again repeat what is the meaning of bay? Bay word is clear. ICT bay, line bay, what is the meaning of that? I will explain again. What is the meaning of line bay?
Hello.
Yeah.
Hello.
Yes, yes, tell me.
Sir, actually, field equipments also included in the for particular way, breaker, isolator, CT, PT also included, na, sir?
Yes, that all switchgear included in the bay.
Yes, yes, understood.
Let me take
Sir,
it.
bus bar also included, sir.
No, bus bar is not included. Let me take any side picture. Let me take any side picture, then I will try to explain what is the meaning of bay. One second. I think we have some snapshot. Some snapshot. Yeah. Can you see this? This is my power trafo here. You can see here this power transformer, right? Please, anyone who ask the questions unmute and we can discuss. So from, and this one is the bus bar. This R phase, Y phase conductor and B phase conductor, this is the bus bar. And from the power transformer we are connecting from the power transformer to this bus. So this circuit that have the LA, CT, breaker, isolator, this complete circuit we called as the bay. This is bay, this is again bay, and from this is again one bay. So this bay is called as the transformer bay. This one, this is again called as the transformer bay, right? So this bay means R phase circuit, Y phase circuit and B phase circuit, including the switchgear also, right? Bus bar is the universal in it is common in the system, so that is not covered. Only this circuit is covered. So this is called as the bay. When we talk about the line bay, it means you can see here, this is my series of the towers, right? You can see this is transmission line here, transmission line here, again we have transmission line, and through that we have connected here. So from this bus bar, you can see, you have seen this bus bar right here, you have seen this bus bar here, that bus bar top view, this is the front view or elevation view. So from here we are, with help of this equipment, we are connecting this bus bar to this transmission line. So this bay we will call as the transmission line bay, right? I hope what is the meaning of bay, this is clear. Bay means this, bay means this circuit, this conductor, this one is the bay. This one is my bay transformer, bay 1 transformer, bay 2 transformer, and this one we can refer as the line bay. Yes, so by taking this, taking this side pictures, we can go to the now project. We understood a line bay 2 numbers. It means we have 2 number of the line bays. This is 1 number line bay. Similarly, we will have 2 number of the line bay. Okay, ICT bay 2 numbers. So this is the picture for the ICT bay. 2 numbers here. We have 2 number of the ICT bay. 1 number here, 1 number here. Right. So this is the line bay 2 numbers, ICT bay 2 numbers. So let us we first understood this word, and then we will convert this statement into terms of the drawings. So we have 2 number line bay. So let me take the line bay. Let me take the line base. Okay, so we are now downloaded one tender, and we are started that tender. And when we start any project, first of all, as a design engineer, we have to review, or we have to check what is the scope of the work. So we have taken one 400 by 220 kilovoltage substation, right? And in this substations we have to make 2 number of the line bay, 2 line bays. It means, first of all, let me draw this rectangle. Let me draw one rectangle. This will represent my boundary of the substation. Just to explain, this will my boundary of the substations. It means we are taking 2 line bay. So the line bay, how it will come? So here we have the transmission line. So let me draw the line. Transmission tower, top view like this, and then 3 line RYB phase it will come. So this is, and below this tower there will be some series of the towers, right? From where this 400 kilovoltage is coming from the sending in substations, right? So there is 2 line bay. So I'm just drawing one single line. So line bay 1 line means, do not take one line. It means there is RYB 3 phase, but all the R phase, Y phase and B phase is similar and equipment is same. So in place of drawing 3 line, I'm just drawing 1 line, and I can cross like this. So this is representing the line bay. This line representing the line bay that will have 3 phase. So this line bay 2, and it is coming to the with help of the circuit breaker. So this symbol representing the circuit breaker. I will use all the equipment here, but just to explain the scope of work, I'm just using one switch gear, that is circuit breaker, and it is coming on the common bus bar. Okay, then going back to the tender, 2 line bay. I think how many how many ICT bay? So we have the 2 ICT bay, right? Yes. So going back to the here, 2 line bay and 2 ICT bay. It means we are taking one circuit from here, then step, and let me make the 2 winding type transformer power dropout symbol just for the easy understanding. This is one trafo, and this is the another trafo. Okay, and this is line ICT bay, 1 bay here. So 1 line bay here, I can put line 1 and line 2. There is 2 line bay, ICT1 here, ICT1, and I can write ICT2. So 2 ICT bay. This line representing the bay, and it is going to 400 by 220 kilovoltage transformer, and that is the 500 MVA capacity, right? So on this side we will get 220 kilovoltage, step down, and on this side we will get the 220 kilovoltage, right? Okay, and thereafter line base clear, ICT base clear. Okay, we have the bus reactor, and that is the 125 m var, and quantity is again two numbers. Bus reactor two number, and that is 125 MVR MVAR, and we have two reactor, that is why we have the two reactor bay. So we have to connect the reactor also here. So we will connect the reactor, and this reactor is coming on the bus. So again we are taking one circuit, then we are putting this to the reactor. Reactor we make just the inductor circuit. This is the reactor, and then it is connected to the ground one side, and this is the reactor. Now let me ask all of you, why we use the reactor, or why,
Compensate the reactive power.
and who will generate the reactive power? Why the compensation of reactive power is required?
Due to this generate the reactive
So
power.
the line shunt capacitance generates.
During
During
no
no
load
load condition,
condition,
the
the
transmission
transmission
line
line
may
and
activate in between the ground and transmission line. There is a capacitance formed, and that's why the reactive power forms up.
Yes,
During
so
the condition.
so to generate the reactive power, there is a certain conditions. The condition number one, this line should be long transmission line. So whenever any long transmission line, second, this line or this trafo for which we are feeding to power with help of this transmission line, when there is a light load or less loading conditions. So whenever there is a long transmission line and that line is less loaded due to any load rejection, due to any major industrial load shutdown, so there will be less loading on this switchyard, on this transformer, and on this transmission line. So when a longer transmission line, whenever there's less loading, and the third conditions, whenever any high voltage system means if the voltage is less, then it will not become very much effective. But whenever high voltage system, high long transmission line, high ground height, and less loading, so if this kind of system exists, in that case the shunt capacitance between the conductor and the ground will inject the reactive power to the system, and whenever the due to the injection of the reactive power by the shunt capacitance, loading is less, reactive power is higher injected by the capacitance, then in that case the voltage will increase. So what is the problem if my voltage is increased? If the voltage is increased, what will happen? All the equipment is designed for the 400 kilovoltage, right? So if this voltage coming around 600 kilovoltage, or if the voltage coming 500 kilovoltage, so what will the problem? This higher voltage will produce the higher electrical stress on the equipment, and due to that higher electrical stress, the equipment insulation may flash over, may puncture, and equipment may flash over, right? So to avoid those kind of this electrical flashover, insulation failure, we have to limit this voltage under the rated voltage. So to compensate that injected reactive power, we have to add the reactor, and uh, and this reactor we required in case of the ultra high voltage substations like 400 kilovoltage, 765 kilovoltage. When we go to the 132 kilovoltage, 33 kilovoltage, 220 kilovoltage, in those kind of the substation, this reactor is not required. Why? Because length, this is not the long transmission line. Those kind of the line is medium transmission line or the short transmission line. Then they, in that case, and the also voltage is less, right? In that case, this reactor will not be required. I hope it is clear that why should be extra high voltage. Yes, yes, Rahul, it should be extra high voltage. So let us take one example. one example on this, why we required this reactor. I have some small write-up on that reactor also. So let us go to the. So we have downloaded the tender today, right? And we are going through the scope of the work, and in the scope of the work we found that there is a reactor used in that substation. So we are going to discuss about the reactor, that why reactor is required. So why we require the shunt reactor? So shunt reactor are used in order to compensate the reactive power generated by the shunt capacitance of the transmission line. Current flowing over long transmission line can have high capacitive component. This usually cause voltage increase. The capacitive component cause the voltage increase, and the effect known as the Ferranti effect, and can cause high voltage values at the receiving end of transmission line in case of less loaded or lightly loaded conditions. So the longer the line is, the higher effect of shunt capacitance. Thus, shunt reactor is an absorber of the reactive power and therefore increasing the active power transfer capacity of the system. Reactor also utilize or regulate the voltage at receiving end bus bar during the light load conditions. Yes, when the load is less, and if 100% loading, then reactor is out of circuit, out of operations. And to control the on and off of the reactor, we use the switchable reactor. We use the isolator and the circuit breaker. I'll coming a video on that topic also, and coming on that. Yes, your point is very valid, that who will control on and off of the reactor. So I'll coming on that point. So here we have one transmission line model. So this is my transmission line that have the inductance L, resistance R, and between the line and this is the ground, we have the shunt capacitance C, and then lines of substance at the G. Right, this is the representation of a transmission line. So transmission line have mainly four parameters: resistance R, inductance L, capacitance C, and the shunt conductance G. These parameters are uniformly distributed along the line. Hence, it is called the distributed parameter of the transmission line. And between this line and the ground, air acts as a dielectric medium between the line and the ground. And we know that if you can take the example of the capacitor, that there is a two conductors, and between the two conductors we have the insulating medium, that is air. So on the both plate we have the charge. So on the ground we have the charge, and there will be some charging current will also flow between this. The charging current will also flow. That we can check through the ETAP. So I'm coming on the ETAP also. Let me cover this basic intro about the reactor. So we discussed that why reactor is required. Further, this reactor is based on the connection. There is two type of the reactor we use: line shunt reactor and the bus shunt reactor. The shunt reactor connected with, and when we connect this shunt reactor with the line, what I mean to say line shunt reactor, it means, as we discussed, that this longer transmission line inject the reactive power. So we can connect this reactor in place of the bus. We can connect this reactor to this line also, right now, to this line also. So when I connect with this kind of the reactor, this is called as the line shunt reactor, because it is connected with help of the line. So when I will go with this type of the connection, suppose there is a two line, there is a multiple of the line, but out of the multiple line, only one line is the longer transmission line, other is short transmission line. So in that case, we can connect this reactor on that line only. No need to connect on the bus, right? So in that case, this type of the connection called as the line reactors. And when we connect this reactor on the bus, so this kind of connections we call as the bus reactor. And this connect between line and the ground. So that is why this kind of connections we call as the shunt connections, and this reactor we call as the shunt reactor. I hope this shunt word is clear, why the shunt is coming. If not, please let me know, and please be active on the chat box. Okay, we are taking one tender. We have seen that in that tender reactor word have been used. So we are going to discuss that what is reactor, why reactor, and how we connect the reactor, and why the shunt is coming. Shunt means the parallel. and any connection between the line and the ground called as the parallel are called as the shunt connections, shunt and series. We sometimes use the series reactor also. Can anyone tell me when we use the series reactor? In place of the shunt, we also use the series reactor. So any idea when we use the series reactor?
Series reactor, sir, in order to minimize the fault level, sir, in the
Correct,
network, sir.
correct. So when we wanted to minimize, we wanted to reduce the fault level or short circuit current level. In that case, we use the series reactor. I will explain the series reactor with help of the ETAP also.
So series reactive is also used on capacitor bank, no sir?
Capacitor bank?
Yes sir.
No, capacitor bank is no, not. Shunt reactor. And one most important point that we have to note here, and I have one engineer, let me ask, Rahmatullah, are you there? Rahmatullah, are you able to unmute? Yeah. So, are you able to unmute or not?
Yes, sir. Yes, sir.
Your voice is less, so you have to speak loudly, Rahmatullah.
Yes, sir. Now please tell me.
Your voice is very less coming to me, so please you increase your volume. Yeah. Okay. So now what happens that
Sir, voice is coming.
your voice is coming very less here. So please. Yeah, Shivam, as I said, when I use the line reactor, when I use the bus reactor, as I said here, as that suppose we have four number of transmission line or five number of transmission line, or suppose we have two number of transmission line. But out of the two number line, one line is longer transmission line. Suppose this is my longer transmission line, any 300-kilometer transmission line, right? And this is short transmission line. Suppose say 100-kilometer or 50-kilometer transmission line. So who will react? Who will inject the reactive power? Which line? Obviously, this line will going to inject the reactive power. Shivam, right now? Am I correct? Because this is the short transmission line, and for the Ferranti effect, this should be long transmission line. Okay, so this is the long transmission line. In that case, if this line is only one line and one line is very long transmission line and this line is injecting the reactive power, so in place of connecting this reactor on the bus, I can connect this reactor in the shunt of this line. Okay, so in that case I will go with the line reactor. And suppose we have two or three or four and all the line are we have two line and both is the very long transmission line around 300 or 400 kilometer. So in place of putting two line reactor, we can put one shunt reactor, and that is on the bus. Okay, Shivam, I hope the selection is clear when I go to the line reactor, when I go to the bus reactor. Yeah, okay, Shivam. So now one important point, actually, Mr. Rahmatullah is working as a consultant in one firm, and he was working in a project. In that project, they are using the reactor, but along with the reactor, they are using the NGR. Rahmatullah, can you explain your difficulty so that we can address here? Okay, no issue. I'll take your problem and will explain to others. But you have to unmute and you have to explain that what difficulties you are facing. No, so I'll take your point. Okay, so the reactor is clear. The reactor is clear. This is why we use the reactor. Now, this reactor is two type, line reactor and the bus reactor. And the next important point that we have to note that when we connect this line reactor, so actually the reactor one side we connect with the bus and the other side we connect with the ground. Here we give the example. You can see here this is R phase, Y phase, B phase. This is connected with help to the circuit to the bus with help of this PI or LACT. And then another part of this reactor, this is looking similar to the transformer, right? And the other side it is connected to the ground. In case of power trafo, we have primary and we have secondary. Here we have the primary and secondary, but secondary is the ground. And secondary side we have only one bushing. So total we have 4 bushings, 3 for the phase, 1 for the grounding, right? So this is side snapshot of the reactor bay. The point is that when we connect the reactor to the bus, then we connect directly. But when we connect the line shunt reactor, the shunt reactor connected with the line are provided with the neutral grounding reactor NGR. I can show you this with help of the drawing. So I have taken the snapshot of this drawing. You can see this is my 500 kilovoltage transmission line, LACVT wave trap. This is all, and we have taken the point here, and this is going to the reactor. This portion is the reactor, and you can see here to control on and off this reactor we are using this circuit breaker with the CST, and here we are using the isolator also. So as you ask Rodeo that how to control this reactor, so control and on and off the reactor we use the circuit breaker that will on and off, and this kind of connections we call as the switchable line reactor. Switchable line reactor. So there is two type of the reactors, switchable and non-switchable. Switchable means when we connect with the breaker, then this is called as the switchable. When we connect directly without any breaker, then this is called as the non-switchables. And generally we go with the switchable line reactors. We connect with the breakers. Okay, Preview, I think I address your query. Okay, next you can see here this reactor is not going directly to the ground. Between the reactor and the ground we have one more equipment. This equipment called the NGR, neutral grounding reactor. Now you can see whenever you work any 400 kilovoltage or 500 kilovoltage system, you will always find this NGR here. So now let me ask all of you why we use the NGR. So why we use the NGR? So that is the
Sir, sometimes fault current is zero sequence fault current is flowing through the ground. So to minimize the ground current, zero sequence fault current, we use neutral grounding reactor.
For that, that is not the 100% reason. Actually, we are using the NGR between the neutral of the reactor and the ground to facilitate single pole auto reclosing of the circuit breaker. Because what will happen when the fault will happen between the breaker there's an arc current that will generate. So if this arc current is not quenched, in that case we cannot do the auto reclosing of that breaker. So with help of the NGR, this NGR enable circuit breaker for the auto reclosing. So this NGR every time we have to provide, that is the agenda, that is the concept number 1. And why NGR? So that this auto reclosing is possible. I will share some document on that. If anyone has any query, they can refer that document, the use of NGR in the auto reclosing. Okay, because if I address this it will again take one day, so I will refer some research paper, but as of now we have to note that NGR is required in order to, yeah, I will say that paper. Okay, for the auto reclosing. So whenever the line reactor, then NGR is required, and whenever in bus reactor, in that case neutral is already grounding, NGR is not required because there is no any auto reclosing we do with the bus. So that is the reason the NGR is not required. I hope this is clear. Ramatullah, to you, your query is addressed. So I hope this bus reactor is clear, that why I am connecting the bus reactor here. So we need to connect the bus reactor here, right? And space for the future line bay 6 number. So we have to put the 6 number future bay here. Okay, as the future we have to indicate, and ICT bay future we have to indicate. So here we can take this, we can extend this line, and 6 number of the future line bay we have to see. So this line we have to draw 6 times 1 2 and similarly we have to run 6 times, and then we have to show 2 number of the future ICT here, right? So thereafter we have this ICT bay 2 number ICT bay means why it is coming, because this side we have the 220 kilovoltage side, so this is 220 kilovoltage side ICT, 220 kilovoltage side ICT, this one, right? ICT it will come on the bus, it will come on the bus, this 2 bus, right? And then next point
Sir, I have one question, sir.
please note your questions, we'll discuss in the last.
Okay,
We
sir.
have one Q&A session. Okay, then we have the line by 6 number, so here we have the 6 number of the 220 kilovoltage line that we have to draw. 3, 4, 5, 6. Okay, so this is how we can convert this statement in terms of the drawings. So I hope this statement here and this sketch is clear to everyone. And why reactor, this is clear. Type of the reactor connections, line and the shunt, this is also clear. Please let me know if anyone have any query with respect to the scope of the work understanding. We discussed today about the scope of the work, so please let me know. The scope of work is clear to everyone. Yeah, okay, tell me your query here. And meanwhile, I will take up your query. Yeah, tell me.
Sir, you will use the reactor this bus, but you cannot use the reactor bus number 2. Why?
Which bus? This bus?
Because here two number of bus line, two number of bay. One bay is one reactor, the other bay is another reactor also used. So why you use one reactor and cannot use the other reactor in bay number 2?
Bay number 2, if this is short line, then not required. If long line, then it is also required. Okay, Indrajit?
Are you drawing the short transmission line?
Yes, it may be. No? I am telling both the case. If short transmission line, then not required, and if long transmission line, then required. So what I am doing that in place of using 2 reactor on the 2 line bay, I can use 1 reactor on the bus, so the quantity will reduce now of the reactor.
Sir, one other. In case of reactor, we can also use a FACS controller.
No.
Flexible AC.
No. We use the circuit breaker. Fact is another device. Okay.
Okay, sir.
No, secondary side not. You follow the tender specifications. You follow the tender specifications, Rohit. If in tender it is written, then you need to select. Yeah, tell me.
Sir, I have one query. In a two transmission, so both transmission line are supporting in one tower.
Yes, 1 tower.
Okay.
Yes, that is the double circuit.
Sometimes they are coming from the different towers.
Yes, it may come. If it is coming from the same location, then same tower. If it is coming from the different location, then it will have different tower. That is clear, yeah. If coming from
Is this for the only for substation?
yeah, if it is coming from the same substation, then it will have the same tower. Okay.
Is what scope only for substation only or transmission line?
Sorry, this is only for the substation.
Okay, sir, got it.
You can see here, na, in the this is taking very much time. ETAP is taking very much time to open. Okay, so let me close this ETAP. Yeah, Siom, tell me. Siom, you asked me to go to the PPT back.
Yeah, sir. Pop up work.
Yeah, a scope of work area.
Pop up area not mentioned in the transmission line, only for substations.
This is only for the substation right now. Establishment of 4 by 220 kilovoltage 2 into 500 MVA service as means substation. Okay.
Okay, sir. Got it.
Okay. Okay. Yeah, Sivam, tell me your query. No, nothing
Nothing
actually. I
actually. I
just
just
wanted to
wanted to
note
note
down
down
something
something
for
for
myself.
myself. So just did it.
Okay. Okay. So I think the reactor is clear, right? The line reactor and the shunt reactor, where we use the line reactor, where we use reactor.
Yes, 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 yes.
Sir,
Hello.
hello.
Yes.
When bus reactor will close circuit breaker. How circuit breaker of bus reactor will close?
Circuit breaker will close means you need to give the closing command to breaker and that will close.
Okay, who will decide that
For
we have to
for that we have the system that will measure the voltage, and we have the relay, and that will take the decision.
Okay, sir.
Yes. Okay. Any other query so far? Okay. Now what is you ask Rodeo? Let me take your query also. What? How is there any standard when we need a transmission line and how to calculate the shunt reactor needed in?
I get that.
See, Rodeo.
Mistake, sir. Is there any standard for the shunt reactor needed
Yes,
in
yes.
transmission lines or
See,
something like that?
when your transmission line is very long transmission line, very long. I mean to say more around 200 or 300 kilometer. Okay.
Okay, sir.
In that case, we require the shunt reactor, and what we do actually, Rodeo, we follow the project. So whether shunt reactor is required or not required, it will come in the tender also. So as per my tender, I am taking shunt reactor. But yes, as per the if we have to take the decisions in that case, we can have one ETAP study. Through that I will explain you that when it is required, when it is not required. And when you talk about the sizing, so it will depend on the length of transmission line, and based on that we will size the shunt reactor rating in MVAR, that how much MVAR it is required. Yes, and that is the correct understanding, Soumya. As a EPC contractor, what are steps he needs to follow before the bidding? I'll go to that process, Soumya.
Okay, sir.
Okay, don't worry about
Thank
the
you, sir.
bidding. And as a EPC contractor, we have to follow whatever given in the tender. So in my tender, it is given the this reactor, shunt reactor. So I'm following shunt reactor.
Sir, one query. BOQ and BOM means.
Bill of quantity, bill of material. Okay, bill of quantity or bill of material, it is called the BOQ. BOQ means bill of quantity. Bill of material, it is called the BOM. And in that we tell about the quantity of the equipments. Okay.
Thank you, sir.
Okay. Yeah, project specific. And for all these small doubts, we can discuss separately also. Okay. This kind of small doubts, please discuss separately. Uh, After the class, we'll have one 10-minute session in that these all things will be discussed. Okay, so okay, Mansoor Sahib, I will send you. No issue, I'll send you. So okay, so this is how we study today about the scope of the work. So we have to go to this further deep into the this different scope of the work. So what I'm trying to say to all of you, in this project I will share this project. I think you all already have this project. So we draw one sketch for the A number serial number. So you all please try similar kind of the sketch for the different project. So project number B, 220 this, 132 kV this, 33 kV this. Project number C, we have different this bus schemes. Project D, we have different number of the scope. So please take this statement of the scope of the work and convert these all statement in terms of the sketch that we draw like this. It will help you all to understand about the scope of the work very easy, like in a crystal clear way. So please take this statement and convert this into form of this sketch. And if anyone facing any difficulty, please let me know. Okay, so this is what we are keeping today, and in the next session we will discuss how to read this standard, and then we will discuss what is the IEC and IETP standard we follow, and then we will do some ETAP simulations, and in the next class we will have session for the ETAP introduction. Today we have planned for the ETAP intro, but we will cover into the next class the ETAP introduction. Franti also will submit by the ETAP.
Sir, can you share this project on a group so we can
okay, I will share this project in the group.
So, sir, for the ETAP, sir, when you will share, sir, the software link?
Which software?
ETAP, sir, ETAP.
When we will come on the ETAP, before that I will share with you. Don't worry.
Okay, sir.
Yes. First of all, we should know how to read the tender. Okay. So let us concentrate on that. How to read any tender. Yeah. So yes, Shivam, what is your query now? So please, now we are closing the class. So now we are entering to the Q&A session. So if anyone have any query, they can discuss. And if for others it is okay, so they can exit. Today we'll not discuss furthermore. So we are entering into the query. So PPT that a single pole article closing, it is specifically for the single pole. So, yes, it is only for the single pole, Shivam, not for the three pole. Okay, because in single pole the one pole will open and remaining two pole is in the service. So for three pole it is not necessary. For single pole it is necessary, because for the single pole you have to immediately close the breaker right now, Shivam. So when you are immediately closing the breaker, before closing the contact, the arc should be quenched. So this NGR will help out in that arc quenching. Okay, so that is the reason. Okay, Pranay, you test me, I will say a bit for that.
Sir,
Yes.
hello. The video recording for yesterday. Where did you send it?
I have not sent it.
Oh, okay.
I will share. Yes, Silpa, tell me.
Actually, I asked you one question regarding power transformers that HV to
Yeah, HV to LV. Yeah, come again, Silpa. Okay, no, so we can take Afzal. Yeah, tell me, Afzal, your query. Yeah, Afzal, come again. Yeah, your voice is breaking. Okay, Afzal. Okay.
Yes, sir. It is better to.
On WhatsApp it is not possible, by mail I will try to share. Okay, so allow me some time, I will share.
Fine, sir.
Fine, sir.
Uh,
Okay.
sir, I have some questions, sir.
Yeah, Rodi, tell me.
Hello, sir. Sir, I have doubt about the type of transformer, sir.
Yeah, tell me what is your doubt.
Usually, sir, for 400 kV transmission line, why they are using auto transformer, sir, instead of two winding? What's the reason, sir?
Yeah, they wanted to reduce the cost of the transformer. That is the reason.
Only the cost, sir. In technical, there's no
Yes,
other
yes,
reason, sir.
no other reason. Only cost reduction is the major reason.
Okay, sir.
Okay.
By the way, sir, these three winding transformers, sir, what is the connection usually, sir?
What is that?
The connection of the winding. Connection of the winding.
Connection is, suppose this is coming from the gas turbine. This is
no, sir. In the winding itself, the three winding.
Yeah,
Why delta?
yes, it may be delta. This may be delta star.
Like this, sir. Okay, sir.
Yeah. Any other query?
Sir, what is the difference between the reactor and FACS controller?
Both is different device.
So,
Both is
in
different
case of
equipment.
power transmission system, static var compensator STATCOM like device is
Yes,
used
so
for
the shunt reactor is a static device. They are not controlling the reactive power continuously when we want. This we have to switch on. This fact is a device that is always connected with the grid, and they are dynamically controlling the reactive power. So fact is an advanced one compared to the reactor.
And custom power devices also used in distribution system.
Which one?
Custom power device CPD.
Yes.
D-STATCOM, distribution static compensator.
Yes, so same the reactive power compensation. Initially we are using the capacitor bank. So in place of the capacitor bank, now we are using this device.
Okay.
Yes.
Sir, please also give the recording of previous class. You have.
Sir,
Okay.
Hello.
sir, in our industry's substation, the capacitor bank, in that reactor is used, sir. HT line, series reactor.
Series reactor for the fault current limitation.
And as well as harmonic, sir, also control that, sir.
Harmonic, but main reason is the to limit the fault control, to reduce the fault level, to reduce the fault current level.
Okay, sir. Okay.
That is the main reason. Yeah. Yes, Silpa, now you can tell me. What is your query regarding to the transformer?
You told that the HV to LV ratio should be less than or greater than 2 to decide if it's a two winding transformer we will use or an auto transformer.
Yes.
I just wanted to know why we have chosen 2 as a limit for that. I mean, there are some economic considerations.
Only the economic considerations. Just to cost is the main concern. Because if you reduce the one winding, in that case, all the copper material, all the winding cost we are neglected, we are reduced. So if I use in place of two winding, single winding transformer, in that case the cost is reduced. And when the voltage ratio is less, in that case what we are doing? So we are just taking the taps between here. So a small portion is left out here. So in place of the two winding and auto transformer, why we are going on the auto transformer, not on the two winding? So main reason is the cost. Why cost? How the cost is reduced? So we are eliminating the one complete winding portion. So this winding portion cost is eliminated. Okay, Shilpa?
Sir, last question, sir. As you discussed about auto transformer transmission line, that you told that it will no. This means that ICT, it means interconnected transformer. That's why we are using auto transformer. How about the IDT, sir? That one also, IDT is an interconnected distribution transformer, sir, no, right?
IDT?
Yeah, we have in Dubai, we are using here from our 400 kV lines is auto transformer, ICT. But from that is 400 bar 132, but our 132 bar 11, we are using IDT. But the winding connection is YN delta.
That is two
Two
winding.
winding.
That is two winding or single winding?
Two windings, sir. Two windings. Y delta.
Okay.
From our 132 bar 11.
Okay, so we have this 132 kilovoltage and this 11 kilovoltage, and this side you have Y and this side you have delta, right?
Yes, sir.
Y and delta.
But we call that one IDT.
Okay, you can call this intermediate distribution transformer. This you can call like this. That is the name that we are given. Yeah, the interconnecting this distribution transformer. This may be.
Yeah, distribution transformer, sir. That's why I have to ask you explain about why this called that ICT because of
This is the name. That is how they are putting the name of this transformer. That is only the name.
Okay.
Yeah, it will. I will explain you, Siddiqui, with help of the ETAP. This query. So please note down. I will explain with help of the ETAP how this weather and terrain will affect the selection of the transformer. Let me open the ETAP. With ETAP, I will explain.
So any standard or any report stating this when to use auto transformer or ICT?
Come again.
Any supporting grid code or I standard?
For which?
For this auto transformer.
Yes, we have the IC 60076 for the auto transformer. We have the grid CA grid rule also, Central Electricity Authority grid rule also.
But that states that given ratio you have to go with this kind of selection. So that states this criteria.
Actually, Salis, this criteria majorly by the CA and majorly by the transformer manufacturer, not by the IC. It is majorly by the CEA, Electricity Code. Yes, they tell it that.
Okay, thank you.
Sir, I have one query.
Yes, tell me.
So, what is at the point of construction in the reactor, there is a air core reactor.
Air core reactor is the fault current limiting reactor, and that we connect into the series.
Okay, and there is a scrap iron core reactor. What is that?
Okay, you test me that photo. I'll tell you that what is that reactor.
Okay.
I'll try Vignesh because the PPT is under the like fine tuning and the completion mode. So better that you all prepare your note. I'll try to share the PPT, but I cannot commit that I'm going to share the PPT. Tender I will share. The IC and IEEE I will share, but for the PPT it's better that you prepare your own note. But I will try to share the PPT also. Okay, Vignesh and Nursing also you have asked the same query.
Hello.
Yeah.
Sir, please exact meaning of the bidding. One sentence, just how I understand the easiest meaning of bidding.
Of
Easiest meaning of bidding.
Bidding is that uh, you are telling that how much cost you will pay. That is the bidding. How much cost you will take to execute that project, that is called the bidding.
Like electricity bill, like tariff.
Yes, like tariff. Yes, same.
like ready.
Yes. Okay.
Sir, the capex of X is a type of bidding. Capex.
No, that is not the type of the bidding.
Okay. Bidding is a part of the tender or construction. EPC under the EPC, engineering, procurement, construction.
Yes.
Okay.
And for this kind of the query, please discuss separately with WhatsApp or by call. Okay. So that in class we can discuss about
Okay, sir. Okay.
syllabus only. And there is a Google also. You can do the Google also. Yeah.
Okay, sir.
Hi, sir.
Yes.
While discussing the auto transformer, we were talking about the tertiary winding, and on that we also added that the tertiary winding eliminates the third harmonic and then EMF balancing.
Yes.
So how does it happen?
Okay, Siom, I will explain with help of the ETAP how it happened, and let me tell how it happens. Actually, in the tertiary winding, we take the delta winding right now. Let me take the tertiary always connect in the delta configurations. So what will happen, Sivam? Whatever the harmonics coming, that will circulate inside this tertiary winding. It will not go out of this winding. Okay. So it will circulate inside here. It will not feed to the source or it will not feed to the load. Okay. So that is why this is eliminating the third harmonics or multiple of third harmonics. If harmonic is coming and it is not fed to the source, it is rotated here and then finish. Then how this they are eliminating the third harmonic or multiple of third harmonic due to the delta connections. They will circulate inside the delta, and it will not feed to the source or it will not feed to the load.
Okay, now let's consider the transformer, which is an auto transformer, let's say 400 by 220, and you have a tertiary winding of, let's say, 33 kV or 22 kV.
22 not comes, 33 comes only.
No, even 22 is there.
Okay, yes, continue.
So this third harmonic will not go to the 33 or 22 kV winding, but it will always go into the 400 to 220.
It will not go anywhere because what will happen? Let me take this auto transformer. This is we have, and then we have the delta right now. See, here we have the 450 kilovolt side, and here we have the 220 kilovolt side right now, and here we have 33 kilovolt side right now.
Yes.
Actually, I understood that this you are telling 220, 22. That is why I told 22.
It doesn't matter.
Yeah. So this is 4 by 220 kilovolt. It's not what will happen. Suppose, and this drawing we can explain like this. Here and then here we are taking tappings, and here we have the delta winding that we are connecting into the delta configurations like this. And whatever the harmonics coming, it will be trapped inside here, and it will not feed this side and it will not feed to this side. Okay, Sivam?
If they are in the same winding, why can't they transfer to the 220 kV side? That's my question.
Same winding means where?
I mean, this the auto transformer, it's a single winding.
Actually,
you have the tap.
Actually, what happens? Let me tell you that third harmonic from where it will come. What is the source of the third harmonic? The third harmonic is produced by what kind of the load? What kind of the load? Unbalanced load is not going to produce the third harmonic. It is going to produce the negative sequence. Okay, you can set the unbalanced load. Okay, or any power electronics divide of the load that have switching, that they are doing the switchings, and that is why the third harmonic is coming. So basically, on this 33 kilovolt side, we use all these equipment right now. All the power electronics comes on the delta side here. It is fed by this winding. No?
Oh, okay.
It is not fitted by this, it is not fitted by this. So that is why here we have the source of the power electronics switchables that may produce the harmonics, third harmonics or multiple of third harmonics. Okay, and that is going to enter here. So here we are putting into the delta.
Okay.
Now it is clear now.
Yeah. And what about the power balancing?
Power balancing, actually what happens, we know that the formula right now, N1 V1, how, what is the formula? This
N1 V1
flux
is equal to
formula, this one and this much, right now.
Yeah.
So what will happen, this side we have the load and this side we have the load right now. Both side we are, here we have the source suppose and here we have the load suppose, right?
Yes.
So this side flux is balanced with here and with here, right? But if I do not put the delta here, so this side flux is not balanced because there is no negative or opposite flux right now.
Okay.
So in order to balance this portion of the winding, we are the manufacturer inherently by default have to provide this winding, and if we put some load here, so this winding load, this portion of the winding is balanced with this load. So this is called as the power balance or flux balance, you can say. Okay, Shiva.
So if this tertiary wind, let's assume that
Yeah,
this tertiary wind is not there, is this transformer going to consume more losses?
yeah, flux will be higher, no? Flux, because there is no opposition flux on this.
So which means the losses will be high.
Yes, losses that is based on the flux, that will be the higher. So in order to balance the flux, we need to provide the winding. There is a two choice. We can take this with help of the bushings, we can put the load, or if we are not taking this out much, so this vendor by default provide, and they can provide the buried delta here. Buried delta means you have the choice. Sometimes if you are not wanted to put tertiary load, then they will provide the winding and they will do the this much current is coming and this much flux is coming and this is flowing in this portion of the winding. But generally we do not take the buried delta, we take these bushings out with this portion, we take out with help of the bushings, and we put our auxiliary load on this side.
Okay.
So that
when you say buried delta, is it just we are leaving it inside?
Yes, inside the tank.
Okay.
Yes.
Okay.
So I hope your both questions addressed right now.
Yes.
So what is the key learning for today's session? What is the key learning?
Key learning, we learned about the type.
Yeah.
Of transformers.
So we learned about the type of the transformer. That is the key learning. Okay. Then why reactor is required and the type of the reactor connection right now.
Right.
Reactor connections. That is the key important learning. Then we discussed that if we have the line reactor, in case of the line reactor, so we have to use the NGR. If we have the shunt reactor, then it is going directly to the ground, no NGR required. Okay. And what is the next learning? This why we take delta and why we take this ICT. So major concern is the price only. Let me take few other query. How tertiary winding connected to the ICT? Tertiary winding is inside this tank, yeah, Mehul. Okay, can you please open the NGR scheme drawing? Okay, I'll coming on that. Can is this folder? Yeah, Ganesh, tell me. Ganesh, are you there?
Sir, these types of drawing you describe please next class.
Yeah, obviously, yeah. I'm today only concern is the tender scope of the work. So we'll discuss drawings throughout the session, yeah. Today agenda, tender download, how to read the tender, and first we have to go the scope of the work. So we discuss the scope of the work and we convert into the sketch. Obviously, we'll explain the next class. Okay, Ganesh. Obviously. Yes, we will explain. And whatever the assignment we have given to all of you, so assignment is that take this project and make the sketch for the similar kind of the other project we have. So at least take 2 or 3 projects. At least take exercise on the part number B, part number C, so that it will be more clear. So this is the home assignment. You work on this project and convert this into the sketch.
Sir, kindly share it on the groups.
I will share this project on the group. Yes. Yeah.
Sir, if I facing any problem to draw this project sketch diagram, so I will call you and please
Do
help.
not call me. We will have the separate session for that. Okay, Indrajit?
Okay, sir. Okay, sir.
Yes, because on the call we are not able to explain. So for that we have the separate session to review the homework. Okay, that will be the separate, not in the class. That may be on the Friday. It may be on the Sunday daytime. Yeah.
Sir, my question is that reactor will take some time to observe reactor process, or immediately it comes at voltage, sir.
Reactor will take some time. Yes, this will take some time.
Before that, some of the equipment will be in place in switch right now, sir. So
Yes.
they can.
Actually, what will happen? Yes, reactor will take some time. But if you see any equipment, the equipment is rated for some higher voltage. I will come on that. We'll explain. Okay, don't worry. We have 2 voltages.
No issue, no issue. Okay.
See, Ganesh, we have 2 voltage rating: nominal voltage and the highest voltage.
Okay, sir.
So that is why we take the 2 voltage rating for each equipment. That normally, if they are full loading, then they are 400 kilovoltage, they can withstand. And if due to the less loading, if a voltage coming higher, so they can withstand 420 kilovoltage, right now.
Yes, sir.
So that is why we take 2 voltage rating for each equipment: nominal voltage rating and the highest voltage rating.
Oh, okay. Before in between that time, reactor will come at the act. Right? Okay,
Yes,
I
yes,
understand.
yes. And suppose if reactor is not coming, then equipment is designed for that much voltage. They can withstand that much voltage also. But equipment life will reduce, so that is why reactor is required.
Right. Okay, thanks.
And that is the reason, Ganesh, we have fact device, static war compensation system (SBC), that is power electronics thyristor based device. So their timing is fast. They can very fastly compensate the reactive power.
Okay.
Yes.
Sir, about the assignment, sir, how to submit? We will submit, sir.
Yeah. So for the submit to assignment, you make the sketch on your pen, on your paper, and then take this picture and send to me. Or you can send into group also.
Okay, sir. No problem.
Yeah.
Thank you, sir.
Okay. Okay. So in the starting, you all have a lot of questions, but I hope that when we proceed into the syllabus, you will understood, and this we can have more discussion on the syllabus.
I have one more.
Okay, Sivam, I will share the research paper. In this week, I will share, Sivam. I need to arrange. Thereafter, I will share about the
I have
NGR.
one more doubt, sir.
Yeah.
In case of bus reactor, why we don't require NGR?
See, are you doing the artery closing?
No, but we need. I think we need switching there also.
Switching is not the problem. The artery closing is the problem.
Okay, so I hope in next class you will explain how it helps in auto recovery.
No, Siddharth, I am going to share the research paper on that.
Okay, okay.
So it will be better that if you go that research paper, they have explained in a very good manner that why NGR, what is the role of the NGR.
Okay.
Okay, I tell here that NGR where required, where not required, and to support my statement, I will share some research paper that is 4-5 page paper only. Okay, so you can easily go through.
Okay, thank you.
Yeah.
Sir, I have a query.
Yes, tell me.
Sir, in the tender which we have discussed right now, we have thought that it has one long transmission line and one short transmission line.
No, we did not thought. Yeah, here is the bus reactor. Okay, so that is why I'm putting. I'm taking the different case. If one long transmission line, one short transmission line, in that case we can put on the line. If suppose we have two long transmission line or three long transmission line, so in place of putting on the line two or three number of line reactor, I'm putting one reactor on the bus, because ultimately we need to compensate the bus voltage, no?
Yes.
Yes, that
So
is.
I think that in our assignment, I am thinking that if we take a scenario of two long transmission lines or one long,
See, do not go that scenario. As a contractor,
I have already discussed one long transmission line.
This is the one long transmission line. Yeah, I have already taken note. If one long transmission line, then we can put on the line only.
Okay.
And Sartaj, as a PC contractor, we need to follow the whatever given in the tender, right now.
Yes, sir.
So just follow what is given in your tender. Actually, I explain here because you will find here line reactor. You can find anywhere line reactor also. So that is why you should know what is line reactor, what is the bus reactor. That is the reason. Here not any line reactor, but sometimes we use line reactor also. Okay. So as a contractor, we need to follow the given project scope of work.
Okay, sir. Thank you.
Okay.
I have one doubt.
Yes, tell me.
Consideration of long transmission line is the length is dependent on the voltage level also, that maybe for 220 kV some if we are considering a long transmission line for reactive compensation, that particular absolute value of length will vary according to the voltage. Maybe it is 400 kV or 220 kV or 765 kV,
Yes,
depending on that.
yes. So the length and voltage is interlinked, Silpa. Yes. So I'll explain with help of the ETAP. We'll do some simulations considering the different voltage and different length. Okay. If we wanted to transmit the long power for 33 kilovoltage, then it is not possible. So to support my statement, I will take ETAP in next class and I will explain with help of the simulations. Okay.
Sir, in my site, I have been like we have using 220 kV Lino line we have been taken. In that one, we had like 9.9 kilometers approximately. It is all. Hello.
Yeah, I'm following you.
Sir, correct. Sir, it is of 9.9 kilometers and it is of 220 kV line. So it comes into the short transmission line, sir.
Yes, it is come into very short transmission line. Yes, Sivan.
Yeah, then maybe what I get to say, I forgot.
Okay, so in that case, reactor is not required first of all. Okay.
I know it, sir. I got it. I got it, sir. I don't have a problem. That is not the problem.
Okay.
I will get back to you, sir, after I'm not doing it continuously.
Okay, no issue, no issue. Any other query?
Okay.
Yeah, anyone have any other query? Please discuss all your queries so that during the class we will follow my syllabus, not all these things. We will follow my syllabus, and in the last we will discuss the your queries, not in middle of the class. Yes, tell me.
Sir.
Yeah.
Sir, if two number of base next project four number of base are given, so I draw the four number of base. So in respect to the four connecting transformer.
No. Do not. Energy follow the tender. Whatever written in the tender, that you need to follow.
Okay.
What you are contractor, you are not the owner. Yeah. Whatever written in the tender, that you need to follow.
Okay, sir. First time, sir, this type of design.
No
Like,
issue. Okay, so please discuss all your queries today so that in the next weekend we follow syllabus, we follow the tender project, not all these small doubts. So please come up with all your queries and we can.
sir, Saturday, next class will be Saturday.
Yes.
Okay.
Raghunath, it is not possible to share all these things in the group. Okay, we'll share individually by your email. Okay. And in the future, because first of all, Raghunath, all the things we are taking from the live and running project. So there might be some conflict because what happens in my previous cases, we have shared the document blindly, and few engineer have forwarded that document to my company for which I am doing the project, and this document is proprietary. This document is not open for all. So it is not possible that I hope that if you work in the project, you understood that document is proprietary. It is not open for all, right? So it is not possible that initially we used to share blindly on the group, but due to that instant that document is going out of the group and document is circulating anywhere and it is reached to the one of my client that he's come that you are discussing my project in the class. So we face that kind of the issues. That is why now we do not share all the documents in the WhatsApp group, and each and every document have their proprietary right. Okay, Raghunath, I hope you understood when you work in the like Shivam. I think you also agree, Shivam, that when you work in any reputed organizations like L&T or GE or Tata, they do not allow to share their document. It is proprietary document. So you can discuss in the class, you can note down in the class, you can what I can say. If otherwise, what will happen? If I have whatever document I'm coming in the class, I have to share. So I cannot take those documents which have the proprietorship, right? So we have to take the general document from the Google. So you cannot have feel of the real project. So to have the real project feeling, please do not ask me that whatever we have we need to share. Whatever open like IC and IEEE, that is also not the open document, but I will try to share. Yeah, that research paper will share for sure. Yes, whatever document that do not have title, that we can share in the group. Yes, survey I will share, the NGR I will share. Like those who do not have the title, those kind of the document, I will share. So I'm going to share the tender right now in the group. Okay, Raghunath?
What about the video recording?
Yeah, I will share, yeah. You have some patience. Okay, I will share the video recording. Please allow me some time for the classes videos.
So as per today's syllabus, this serial number 7, 8, 9, 10, those will be taken in the next session, no, sir?
What you are telling?
If you refer to today's syllabus, today's the Excel file.
Yeah, next class, yeah.
Yeah, the next
class.
7, 8, 9, 10. Okay.
Next class. No, I told you next class. Because we are going to discuss all these your other queries, so that is the reason we'll take in the next class. So please, anyone if any query, please let me know. For the classes recording, allow us some time. We are making some platform. So on those platform, we will upload the classes recording. Okay, Vignesh, Raghunath, and Rodeo to ask about the recording. So that is we telling you. Okay, anyone have any other queries? Please discuss all your queries so that in the next class we can follow the syllabus, the agenda, the tender, these things.
Sir,
will you share a single pole auto regulation file?
Come again.
Sir, will you share a single pole auto regulation file?
There is no any file. That is the mechanism. Mehul, sometimes what happens that you all guys not aware with this kind of the system. So sometimes please keep some patience. After the class, you will learn. Okay. Yeah. Okay, Salis. Good night. Vignesh not recorded video is not in the group. We will share by the mail. Again, same reason Vignesh, because in the recorded video we are going to use many company drawings. Okay, so that is the reason we are not putting in the group. That we will share by the email.
Or should we send our email on the group?
Email, already have your all email ID. Already we have your email.
I don't think I have mine.
Yes, you can send, but already we have your email ID. Rodeo, you are asking right now?
Oh, Jumail, this is Jumail.
Yeah, okay. You test me personally your email ID.
Okay.
Yes. Yeah, Ganesh, I will try to keep it 30. Yes, Ganesh, 8:30 will start. Don't worry. Okay. Any other query, please let me know. So I think we conclude something. Whatever the document that have the title, that have the proprietary, and the recordings we cannot share in the group, that we will share by the email. Okay. And if any document have proprietorship, so that document we cannot share by email also. So we will, if that document is required, so we will take a snapshot and by other media we will try to share. Okay. Class recording, we are making one platform, so on that platform we will upload the class recording, so it is available for everyone. And if that platform is not ready by this week, so we will share by transfer or by on your email ID. So for the recording, just please give us 1 week time, most max to max.
Sir, hello.
Otherwise I will try to share both as today and as class recording by email. Okay.
Hello, sir.
Yeah.
Sir, I'm Indranil. Next Sunday I am busy for my work, so you can only send me the Sunday.
Okay.
Okay, sir.
Okay. Anyone, any other query? Please discuss all these things. Silpa, hope your query is addressed right now. Your traffic query is addressed.
Yes, sir. Actually, I have one query related to my work in case of reactive compensation. Actually, I am working in a generating station where we have 220 kV switchyard.
Okay.
And we are facing persistent low voltage issue there.
Low voltage issue means okay.
The voltage, actually, sir, the voltage fluctuation is very much, maybe because there is solar power injection in that nearby grid. Okay. So voltage is fluctuating somewhere from 195 to it may go around 220, sometimes 225, sometimes 230 also within one single day. So I wanted to discuss this issue with you actually. So I thought I will talk to you over phone maybe after.
Yes, we can discuss separately that issue, because that is the same reason, because of you have the solar grid, solar power plant, and they are injecting right now. So
yes.
There might be that reason, because they consume the reactive power, they inject the reactive power. So yeah, that is the major reason.
Yes, so sir, because of that, because we are thermal power plant, so we are facing some generator winding temperature heating issues because of that.
Correct.
Because of the voltage variation when the voltage is low.
Yes.
So I just wanted to discuss with you. Maybe, sir, whenever you find time, I will just call you.
Sure.
Okay, sir. Thank you.
Sure. Yeah. Okay. Any other query? Any other? Or if no query, so we can bind up for today. Next class we have on the next Saturday.
Sir, I am Arulmani, sir.
Yeah, Arulmani.
Sir, you have any class on Friday, sir? You told me that Friday also.
I will try to keep on the Friday also, Arulmani. Yes, yes. Not this Friday, but after 1 or 2 week, we will try to keep on the Friday also. But I'm not like committing that we'll keep this Friday. We'll try to keep on Friday also. If syllabus could not proceed in that case.
Okay, sir.
Yeah. Or if you have all have this kind of basic queries, so we can have a session on the Friday to address the basic queries, and Saturday Sunday we can discuss the class agenda like that. Okay, Arunmani. Yeah, Acharya.
Okay, sir.
Acharya, do you have any query at this Monday?
No, sir. Currently, I don't have any queries.
Okay. Okay, so we can wind up for today.
Okay, then here press on customize controls and scroll down, and here we have screen recording. Just add this option. Okay, and now we appear in the control center. Let's exit and swipe. And here is the icon for screen recording. If you push it long on this icon, from here you can turn it on the microphone and you can start recording. Also, if you exit and let's do it again, just press now on this icon and in 3, 2, 1.
Okay, so we close for today. Okay. Yeah. Good night. So any
Okay, sir.
feedback?
Thank you.
Any feedback for the today session? Any? Okay. So we'll close for today.
Today's feedback.
Hello?
Yeah.
I just sent my email in the group.
Okay, I'll
Alright.
I'll phone you in a minute.
Okay. All right. Thank you.
Thank you.